In this video, we're going to continue our factoring of polynomials, including trinomials that have leading coefficients greater than 1, and a difference of squares, and difference in this case just meaning subtraction of some squared values that we'll see. Factoring is going to be very important for us as we move throughout the school year, so we're just taking some time here to see some strategies. Now, in terms of factoring trinomials, one thing we're going to focus on today, you'll see it throughout, is we're going to check for common factors, meaning in our polynomial, are we able to divide all the terms by a common value? Sometimes we will, many times we won't. As far as factoring trinomials goes, it's the same as what we've done before. If we see three terms, we can go through a process known as split the middle. And with this process, first things we want to do is identify what our coefficients are. In this case, we have coefficients of 7, -44, and 12, and as long as our polynomial is in standard order from highest exponent down, these are the values for A, B, and C. And we want to be careful that we are keeping track of our positive and negative values. Okay, so split the middle, we take A times C. Now what's different today is A is going to be a value different than 1. So go through the multiplication. A times C would be 7 times 12. And that gives you a positive 84. And something to think about is if you're multiplying to a positive number, then that would mean that the two values we are working with are either both positive or they are both negative. Now, as far as adding, we want to add to that middle term of -44. And so what we want are two numbers that fit in both spots. And planning ahead, if the two numbers I choose have to multiply to positive 84, but combine to a -44, then I now know that the two numbers I want are two negative values, because those will multiply to a positive 84 and combine to a -44. So we can start making a list here of values that multiply to 84. And there are a few options we could talk about, but an easy place to start is start with 1 times something, in this case -1 times -84. And you can check to see if those add to -44, and they do not. So we can move on to -2 times -42. And ask ourselves if those combine to -44. And in this case, they do. So this is a good point to stop. You could keep making your list of values that would multiply to the desired 84 here. But once we have the two numbers that we need, there's no reason to continue on. So we have found the two values that will fit into both columns. And so in this idea of split the middle, we take our original trinomial, which was 7x squared minus 44x plus 12, and we split up that middle term into the two values that we have now found, which were -2x and -42x. So what is important is that these two numbers that we have chosen combine back to that middle term. And then we just bring down our first term of 7x squared and the last term of plus 12, and this should look very familiar to what we just did with factoring polynomials last time. So now that we have our four terms, as far as strategy goes, that's an even amount of terms here. We can group those to where we have a first half of two terms and a second half of two terms. In this grouping stage, what we are looking at is what does each half have as a common factor. So we look at these first two terms, we see they both have a variable of x. So we could divide both by a common factor of x, and that seems to be it because 7 and 2 have no common factor other than 1. So we'll divide this first half by x, and so we can rewrite it as x times 7x minus 2. And you'll notice that if you multiply this x throughout the parentheses, it'll give you 7x squared minus 2x, which is what we had up here in green. Now for this next half, if you recall, we need to divide by something that gives us a common factor of 7x minus 2. So we need to divide by something that's going to give us a result that starts with a positive 7. Well, the only way to divide this -42 by something and end up with a positive 7 is if we're dividing by a negative number. So a general rule, remember, is if your terms start with a negative, we'll divide by a negative. And in this case, if we divide by a -6, we are going to have that 7x that we are wanting. And that is our greatest common factor here. We see that the 12 does not have an x, so we cannot divide by a variable. So we'll divide by this -6 and do a rewrite of this half as -6 times 7x minus 2. And again, it seems strange to do, but if we distribute this -6 back in, we're going to end up with what's in green, which is -42x plus 12. So we are rewriting the original polynomial, but we are not actually changing the value, the simplified value of 7 from what we started with. So once we get to this point, we see something nice here, that our two factors in parentheses, these two binomials match. And so if we simply bring out that factor of 7x minus 2, when we bring that away, the question is, what do we have remaining? We have an x in purple and a -6 in orange, and that would be our other factor. So overall, split the middle process is very similar. It's just we might have to do a little more work finding the numbers we need, because the a value that we are working with is something other than 1. So let's try this again. And number 2 is a little different for the reason that we have a number. We have 3 values in the trinomial that are all divisible by something. Okay. So before I ever get started, an easy thing to do here is see what I can bring away. And when I look at these 3 terms, it does appear that I can divide them all by 2. So I would prefer to rewrite this polynomial as 2 times something else. It's going to give us smaller values, which makes our overall work a little bit easier to do. So divide by 2 in each term, and we should have 6x squared minus 11x minus 35. And again, we are rewriting the problem, but we are not changing what we had. If we distribute this 2 throughout the parentheses here, we will be back at our original polynomial. So this is equivalent to what we started with, but it is a little bit easier to work with. And since we've made these smaller values, that's what I'm going to use when I factor. I'm going to focus on this new trinomial here that has an a value of 6, a b value of -11, and a c value of -35. So now, before we get started, we fill out this chart to figure out what numbers we can use to split the middle. And in this case, we need to take a times c, which is -210, and the value for b is -11. Okay, and so what we can do now is we can start figuring out what numbers can multiply to -210. If we're multiplying to a negative, we do know that we need a positive number and a negative number. And because we're going to combine these two numbers that have different signs to be a -11, that is going to mean that the negative number is going to be the larger number. So you can start listing these out. You can start with the very basic idea of 1 times -210. Pretty obvious, those will not combine to -11. So you can move on. 2 times -105. And we continue this process until we find the 2 values we have. So I went ahead and made this list rather than making you watch me do it. And we see it can get a little extensive, and I could have kept going, but there's no reason to, because I've found the 2 numbers that will work. I have a 10 and a -21, and it just so happens that 10 minus 21 gives us that -11 value. And I should also note that you don't have to make such a long list. If it was obvious to you that these numbers were never going to combine to something as small as -11, then there was really no need to do that. And if you have that recognition, it might just save you some time, but overall, we're still going to get to the same end result. And so we see that these are the numbers we're going to use that fit into both columns. And so we are ready to go ahead and split the middle with our original polynomial, or with our new polynomial act. So let's go ahead and Bring down this rewrite of our polynomial where we had a 2 that we had brought out times 6x squared minus 11x minus 35. And you might be wondering, what if we never brought out the 2 in the beginning? What if we never rewrote this so that a and b and c were these three numbers? Could we still split the middle? And the answer is yes. The only difference is you're going to have larger numbers to work with in your table, and there's going to be a factor in the end that has a common factor of 2 that we'll still need to bring out at that time. So whether you bring it out in the beginning or the end, it's up to you, but at some point we really should practice that, bringing out this greatest common factor, and it's just easier to do it at the beginning sometimes because we get these smaller values to work with. So as far as splitting the middle, we just need to look at this trinomial. We don't need the 2 right now. We can actually just save that for later. That's not going to be needed for a little while. What we do need is to rewrite this polynomial. So let's split up this negative 11 with the two numbers we had, which were positive 10. So I'll use plus for positive, and a negative 21. Both of those need an x because they combine right back to that middle term we started with. And then we have a minus 35 at the end and a 6x squared in the beginning. And so now we have the 1, 2, 3, 4 terms. We are ready to break this into two halves and group. What can we bring out of each group? And we see the first group, there's actually two things we're going to divide by. We see that both coefficients are even, so we can divide those by 2. And we see both terms have an x, so we can divide both of those terms by x, meaning we can rewrite those two terms as 2x times 3x plus 5. And if you check that one more time, if we multiply this 2x back through parentheses, we'll have what we had in red, 6x squared plus 10x. So we have rewritten, but we have not changed. Okay, and so then we need to do the same with the second half. And just like before, we see that this half is starting with a negative value. So we're going to need to divide by a negative. And to have a factor that says 3x plus 5, we're going to need to divide by a negative 7 in each case. And so our rewrite would be negative 7 times 3x plus 5. And the good news is we have the common factors there like we wanted. Both parts have a 3x plus 5. And so if we bring that 3x plus 5 out from the expression, the question is, what do we still have remaining? So we take these away from each half, and we see that we have a 2x in green and a minus 7 in blue. And that would be our second factor here. And so we have our two factors of 3x plus 5 and 2x minus 7 that give us the trinomial with coefficients of 6, negative 11, and negative 35. But our original polynomial had coefficients of 12, negative 22, and negative 70. And that's because we brought out a 2 very early on. And so we still need this 2 in order to get all the way back to the original polynomial. Okay, and that one is completely factored. So just a little application of this, nothing too complicated, is let's tie this into geometry really quickly. And we have area of a rectangle equals x squared minus 130x plus 4,200 square feet. Seems like a very large number, but we might have some strategy to use on this one. What we're given is that the width of the rectangle is x minus 70 feet. So we could get a visualization here if we wanted. We could show that the width of this rectangle is x minus 70. And we could show, if we wanted to, that the area is x squared minus 130x plus 4,200. And the question is, what would the length have to be over here to get us that? And there's a couple ways we can approach this. We know that the area of a rectangle is your length times your width, and so we could try to figure out what could we write inside of here to multiply with that to get our area. But an algebraic approach, another approach would be, let's use what we've been practicing and let's factor our area to figure out what these two factors would be. So we see now that we have a polynomial with coefficients of 1, negative 130, and 4200. And because that's a trinomial, we can use our split the middle idea, where a times c would be 1 times 4200. So that would be positive 4200. And we're going to combine to a negative 130. And again, that's tipping me off. If I need to multiply to a positive value, I know the signs have to be the same. If I'm going to combine to a negative value, that means that both signs are going to be negative. So we could start at the very early beginning. We could start talking about negative 1 times negative 4200. However, that is very far away from this combined total of negative 130. We could be making this list for a long time if we're not being a little strategic. So I'm thinking if these numbers are so big, we need to divide by something bigger so that we don't have one number that's small and one number that's just far too large. So rather than starting at 1 and 2, I'm going to jump ahead and see if that buys me any time. Let's jump ahead to maybe 10. If we go to 10, we have negative 10 times negative 420. And even that is just too large. That combines to negative 430. So obviously we need to jump a little more. So maybe I try negative 15. And if that's too much, I'll just back up. But negative 15 times negative 280 multiplies to 4200. And again, that combines to a total of negative 295, getting closer to the negative 130, but still too much. So I'm going to jump even farther. And if I ever jump too far, I can always backtrack. But let's go to negative 20. And we see that if we take 4200 divided by 20, we're going to get negative 210. Still not enough, but getting closer. These combine to negative 230. So at this point, I'm just going to start going by intervals of 10 to see if anything's going to help me out. So I went ahead and tried negative 30, negative 40, and negative 50, and it appears I'm getting closer and closer. The last case combines to negative 134. It's very close. And so I imagine if I just try another, such as negative 60, and I find that that multiplies with negative 70, there we go. We have these two values that combine to negative 130. And so we have found the two numbers that fit into both columns. Those are the two values that we can split the middle with. So we go back to the original polynomial. We had x squared minus 130x plus 4200. Let's break that up. So we'd split the middle with our negative 60x and negative 70x. We still have our plus 4200 at the beginning and x squared at the beginning, the plus 4200 at the end. There's the four terms that we're going to work with. So we look at the first half, then the second. And in the first half, we can divide both terms by x. And when we do, we have x times x minus 60 as the rewrite of that half. And in the beginning, or at the end here, sorry, we can divide both terms by negative 70. And we need to divide by a negative 70 because that's going to give us a factor that starts with a positive x like this one does. And we get x minus 60, which is exactly what we wanted to happen. We wanted these two terms to match. And so we have as our factored polynomial, one factor that says x minus 60, and the other factor multiplying with it, which is x minus 70. And that's something to note. With factors, they are two things that multiply back to the polynomial. And that's the idea of this multiplication, because in this particular problem, area is multiplying two values together, in this case, these two factors. And we are asked to find the length of the rectangle. Well, we already knew the width was x minus 70, and you might notice that's what's showing up here. We have the width right here. And so if that's our width, then the other value, the other quantity that we're multiplying with it must be our length. And so now I know that to get this area, we need to take x minus 60 times x minus 70. And so the length of this rectangle is simply going to be x minus 70. And we are measuring in feet. And so that's just one way we can start using factoring, is to apply it to a simple idea that we know from the past, area of a rectangle. And again, using some mental math here, we could have maybe deduced that this term had to start with x because x times x is going to give us x squared. And we might have also been able to figure out that a negative 60 was needed here in our length, so that when we multiply it, we take negative 60 times negative 70, which is going to force our area to end with that positive 4,200. Okay, in our next value, we're going to look at another setup where we only have two terms and how we can factor those.